Hello, my name is Keegan Goodell, and this is my presentation for Physics 2212 Lab 1 charge tapes. The purpose of this experiment is to understand how to create a line charge and how its results are different than using a point charge for representation of forces on charged tape. The preview of the main results of the experiment are that the charged pieces of tape repelled each other as expected. The charge of the tape represented as a point charge is 3.3 times 10 to the negative 8th coulomb, and the charge of the tape represented as a line charge is 4.7 times 10 to the negative 8th coulomb. The fundamental principles in this experiment are firstly Newton's second law, which states that force is equal to mass times acceleration, and if the net force is 0, then it is in static equilibrium, or there is no acceleration. Newton's third law, which is the law of equal and opposite reaction forces. Coulomb's law, which states that like charges repel and opposite charges attract, as well as a fundamental theory for equations that we'll later get into, and superposition, which is the idea that one large point charge, as made in our first computational model, can actually be represented as a line of smaller point charges that sum to the net force, rather than being represented as one large point charge. As for the overview of this experiment, there were two parts, one of which was setting up the U-tape by putting it on top of a base tape, taking it off, creating a charge, putting it on two books, and then creating a second U-tape, repelling them from each other and measuring the distance to get charge, electric field, and electric force. And in the second part, it was the exact same, except you are representing the tape as a line of small point charges instead of one point charge. As for the system and surrounding of the experiment, the system is tape A and tape B, the surrounding is everything else, and the measurements for length, width, mass, and distance are below. As for the assumptions in this experiment, first, to determine the amount of force on the floating tape, we had to assume that each U-tape made had the same amount of charge. We had to assume that all the charge was equally distributed throughout the length of the tape in the second portion, and that all of the charge in the tape was concentrated in one point charge for the first portion of this experiment. Also, we had to assume the tapes were equal in mass, length, and charge, and we had to assume that the charge did not diminish over time or from holding it on either end. Another notable assumption was that only gravity and electric forces were acting on the tape, and that there were no friction forces or anything else to ensure that it was in static equilibrium. These are the questions asked during the experimentation phase of this lab, which put the previously discussed fundamental principles into action. Here we have the in-lab questions part 2, which are just simple calculations on how we got different values for the questions asked in the lab. Now, some calculations were in the last slide, but others are here where we show with the data calculations in code how we achieved our first result in part 1. As you can see here, for our results in part 1, the charge on the particle or tape is 3.3 times 10 to the negative 8th coulomb. The magnitude of the force of gravity on particle B is 2 times 10 to the negative 3rd newtons, and the magnitude of the electric force on both particle A and B is 2 times 10 to the negative 3rd newtons, because they are equal and opposite reactions as stated by Newton's third law. As we begin here for part 2 of the experiment, this is the data and code and bit of calculations for it. And as you can see here are the results for part 2. The green arrows represent the small electric forces on each point charge by the blue line, the tape. And when you combine all the arrows together, it is the value for the total electric force, our superposition. And as you can see, the estimated charge on the tape is 4.7 times 10 to the negative 8th, and the magnitude of the electric force is still 2 times 10 to the negative 3rd, and the magnitude of the gravitational force is 2 times 10 to the negative 3rd. And here we are with our final questions, which is asking what happens if the charges of electrons and protons switched? And the answer would be nothing. There would be no difference in the distance measured because they would be like charges and would still repel. However, when they're interacting with negatively charged objects now, such as a plastic pen, the two objects would attract instead of repel this time. And the final question in this experiment is, why is there a difference in the point charge calculated and the line of charges calculated? And the answer, simply put, is that these two values are different because the tape is now being broken into small segments of point charges instead of one large point charge. So for a single point charge, the force is pointing in one direction, and in the line of point charges of the segment, they're all pointing in sort of different directions, which changes the value of r hat and hence changes the value of the charge calculated. Now, as for which is a better representation of real life, it would have to be the second one with a line of point charges, because you can't concentrate all of the charge of a length of L into one point. It would be equally, or at least relatively, distributed throughout the whole length. Thank you for listening to my presentation and have a good day.